Hi, here we are given above or below pretty much here is the schematic map of the metro lines in a city with rectangles denoting terminal stations, example A. So we have A, C, D, B, M, P, Q, N. These are the 8 terminal stations. Okay, so terminal stations are basically those stations where a metro train will start or finally stop at. ठीक है. Now diamond denoting junction stations R, T, V, S. These are the diamond shaped stations, and these are denoting junction stations, and the small filled up circles denoting other stations. So all these black dots here are other stations. Now each train runs either in east-west or north-south direction. So either it is east-west, so these are two routes MN and PQ, or north-south is one is AB and the other is CD. So these are the 4 routes that we have. 2 are east-west and 2 are north-south. Okay. But not both. So a train runs only in east-west direction or only in north-south direction, not in both. Fine. So this means that a train starting from A can only go to B, or starting from B can only go to A. It cannot go to any other terminal station. Similarly, a train starting from M will go to N, or a train starting from N will go to M only and not any other stations. Okay. Next is all trains stop for 2 minutes at each of the junction stations. Junction stations are R, S, V, T. So trains will stop at 2 minutes once they reach this junction stations, and for 1 minute at each of the other stations. So all these black circles, the trains will stop at these black circles for exactly 1 minute. It takes 2 minutes to reach the next station for trains going in east-west direction. So trains going in east-west direction. So for example, a train which is at this junction or at this station, to go from here to here, it takes 2 minutes. To go from here to here, 2 minutes, so on. To go from here to here, 2 minutes. To go from here to here, 2 minutes, and so on. So in the east-west direction, it takes 2 minutes, and it takes 3 minutes to go from north-south direction between any 2 stations. So to go from this station till V, it will take 3 minutes in the north-south direction. To go from V till next station, it will take another 3 minutes, 3 minutes, 3 minutes, and so on. Okay? Fine. Next is, for each terminal station, the first train starts at 6 AM. The last train leaves the terminal stations at midnight. So a train starting from B, the first train starting from B will be at 6 AM and the last will be at 12 midnight. And same is the case for all these terminal stations A, B, C, D, P, Q, M and N. Fine. Now, otherwise, during the service hours, there are metro service every 15 minutes in the north-south direction and every 10 minutes in the east-west direction. So in the north-south direction, let's talk about terminal B. The first train starts at 6 AM towards A. And in the north-south direction, there is a train every 15 minutes. So the other train, next station, a train starting from B will be at 6:15 AM. A train after this will be again 15 minutes after 6:15 at 6:30 AM. Next train starting from B will be at 6:45, and then 7, then 7:15, and so on. Similarly, in the east-west direction, a train is at every 10 minutes. So if the first train starts from M at 6 AM, the next will start at 6:10 AM, then 6:20 AM, and so on. Okay? Fine. Okay. A train must rest for at least 15 minutes after completing a trip at the terminal station before it can undertake the next trip in the reverse direction. So for example, a train starting from M will reach N at certain point of time, right? Once it reaches N, this same train can again go back to M, but only after resting for 15 minutes, right? So when it is required, we'll consider this information. We'll see to it. We'll come back to it again later when it is required. Fine. All questions are related to this metro service only. Assume that if someone reaches a station exactly at the time a train is supposed to leave, he or she can catch the train. Fine. So if let's say a train is going to start from C at 6 AM and a person reaches C at 6 a.m. So this person can catch this train. That's what it is given in the last point. Okay? Chalo. So here we have to solve all the 5 questions separately. So let's start with the questions one by one. First question here is, if Hari is ready to board a train at 8:05 a.m. from station M. So Hari here reaches station M at 8:05 a.m. Then when is the earliest that he can reach N? So we have to figure out how long will it take for Hari to reach N. Okay, fine. So let's first of all see which is the train that Hari can catch. We know the first train from M is at 6 a.m. and the train is after every 15 minutes in the, after every 10 minutes in the east-west direction. So after every 10 minutes will be, after 6 a.m. the next train will be 6:10, then 6:20, 6:30, 6:40, 6:50 and so on, till a train will leave station M at 8 a.m. and after 8 a.m. the next train will be at 8:10 a.m. So Hari, since he reaches at 8:05 a.m., Hari will not be able to catch this train, Hari will be able to catch this train. So Hari's journey will start at 8:10 a.m. and not at 8:05 a.m. So starting at 8:10 a.m., what is the total time that Hari will take to travel from M to N? Now the total travel time, the total time taken is, first of all, the traveling time plus the stoppages time. A metro going from M to N travels for some time and it also stops at each of these stations, right? So let's first calculate what is the travel time total. Now to go from any station to adjacent station in the east-west direction, it takes 2 minutes. So how many journeys it has to cover? M to this circle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 into 2. So the total traveling time is 20 into 2, 40 minutes. Okay. Plus there will be a stoppage time. Now stoppage time will be either at these circular stations or either at these diamond junctions. Okay. So let's count these circle stations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So each of these 17 stations the train will stop for 1 minute. So total stoppage time is 17 minutes. And then you have 2 junctions, and at each of these 2 junctions the train will stop for 2 minutes each. So total stoppage time will be 4 minutes. So the total time taken is stoppage time of 4 plus 17, 21, and the traveling time of 40. 40 plus 21 is 61 minutes. So the total traveling time or total time taken to go from M to N is 61 minutes. Okay. So after 8:10 a.m. 61 minutes is 1 hour plus 1 minute. So 1 hour after 8:10 is 9:10 a.m. plus 1 minute is 9:11 a.m. So the correct answer to this question is option D, 9:11 a.m. Hari will reach station N at 9:11 a.m. Okay. Let's look at the next question. In this question, it is given that if Priya is ready to board a train at 10:25 a.m. from station T. Okay, so sorry. Priya reaches station T at 10:25 a.m. and we have to figure out what is the earliest that she can reach station S. So she has to reach S. So to go from T to S, either Priya can take this route TRS or Priya can take this route TVS. Okay. So let's first consider the TRS route. Now if she has to take the TRS route, that means first she will have to take a train coming from B. She will board at T, go to R, and then from R she will have to take a train coming from M and board that train at R and go to S. Fine. So let's look at a train coming from B to T, which is the earliest train she can board if she reaches this station T at 10:25. So the first train leaving B is at 6 a.m. going towards T. So time taken to go from B to T, what is it? In the north-south direction, travel time is 3 minutes. So 3 minutes travel time here, 3 minutes here, 3 minutes here. 1 minute stoppage time, 1 minute stoppage time, and a 2 minute stoppage time over here. So 3 plus 3 plus 3 is 9, 10, 11, 12, 13. So after 6 a.m., the first train that will leave T will be at 6:13. I am taking the stoppage time of 2 minutes here. Although the train coming from B will reach T at 6:11, but it will stop for 2 minutes and then start from T. So this 6:13 is the time the first train will leave T towards R. Okay. This is the first train that will leave T towards R. And we know in the north-south direction, a train leaves every 15 minutes. So after 6:13, the next train will leave 15 minutes after this. So that will be 6:28. Then again 13 minutes after this. So that will be 6:28 plus 15, 6:43, and so on. So there will be a train leaving T at 10:13, right? And after that there will be a train leaving at 10:28. So 10:13 train Priya will not be able to catch, but Priya can catch the train leaving at 10:28 a.m. right? So Priya can start latest by 10:28 from here, and from 10:28 she will reach R by what time? Let's figure that out. So the traveling time here will be 3 plus 3 plus 3 plus 3 minutes, and the stoppage time is 1, 1, 1. So 3 4s are 12, 13, 14, 15. So after 10:28 it will take Priya 15 minutes to reach R. So Priya reaches R at 10:28 plus 15 is 10:43 a.m. So Priya reaches R at 10:43 a.m. So the earliest train Priya can take is the train which leaves R at 10:43 towards S. Okay. So let's look at trains starting from M start at 6 a.m. and what is the time that they can reach R. So we know in the east-west direction the traveling time is 2 minutes and the stoppage time here is 1, 1, 1 and 2 minutes here. So the latest train which will leave R will be at what time? We are trying to figure that out. So a train coming from M to R will leave R at what time? 2 plus 2 plus 2 plus 2 plus 2. This is 5 times 10, 11, 12. Or sorry, rather. First of all, traveling time is 2 4s are 8, then 9, 10, 11, 12, 13. Okay. So a train starting from M at 6 a.m. will leave R latest by 6:13. If we don't consider this waiting time at R, the train here will reach at 6:11. The train will reach at 6:11, but it will stop for 2 minutes here and leave at 6:13. So the first train that will leave is at 6:13. Okay. If this is the first train leaving at 6:13, the next train will be after 10 minutes in the east-west direction. So next train will be at 6:23, then 6:33, then 6:43, so on. So there will be a train leaving at 10:33 and then there will be a train leaving at 10:43. So as soon as Priya reaches R, there will be a train which is going to leave at 10:43. So she will immediately board this train, right? And as soon as she boards this train, she will immediately leave for S. Okay. So now to go from R to S, what will be the time taken? Time taken will be 2 plus 2 plus 2, 2, 2, 2, 2, 2, 2, 2. This is the traveling time. And then waiting time is 1, 1, 1, 1, 1, 1, 1, 1, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 into 2, 20 minutes of traveling time plus stoppage time of 1, 2, 3, 4, 5, 6, 7, 8, 9. So 20 plus 9 is 29. So a traveling time of 20, total time to go from R to S is 29 minutes, right? So after 10:43, it will take her 29 minutes. So 29 minutes after this will be 11:12. So she reaches here at 11:12 a.m. So if Priya starts from T, goes to R and then reaches S, she will reach S at 11:12 a.m. So again, repeating what we did here is, if Priya is going to take this route TRS, we first calculated which is the latest train she can board. So a train which starts from B will reach T by 11:26 am. It will stop for 2 minutes and then start from T at 10:28. So the latest train Priya can board is a train which leaves T at 10:28. It takes 15 minutes to reach R, so Priya reaches R at exactly 10:43. Now a train starting from M will reach, the first train will reach R at 6:11 am, but it will be waiting for 2 minutes, so it will leave R at 6:13 am. The first train leaving R is at 6:13 am and there is a train leaving R every 10 minutes, right? So the train, that latest train that Priya can board would be the train leaving at 10:43, right? So the first train leaving R is at 6:13 and there will be a train leaving every 10 minutes. So every 10 minutes, 6:13, 6:23, 33, 43, 53, then 7:03, then 7:13. So 6:13 is possible, 7:13, then 8:13, 9:13, 10:13. After 10:13 there will be 10:23, 10:33 and then 10:43. So there will be a train leaving at 10:33 which Priya obviously cannot board because she reaches at 10:43, but she can board a train leaving at 10:43. Okay, and after that Priya, this train will take exactly 29 minutes to reach S. Now I am not considering the waiting time here for S because Priya just have to reach here. She does not have to board this train to go anywhere else. So she reaches S at after 29 minutes. So 10:43 plus 29 minutes is 11:12 am. Okay, cool. Now considering the other case that Priya goes from T to V and then to S. Okay, so if Priya reaches T at 10:25 am. So a train starting from P at 6 am will reach T at 6:11 am. We calculated this for M and R, right? So same is going to be the case for P to T. And this 6:11 am reaching train will depart T at 6:13 am, right? So the first train that will depart T towards V is at 6:13 am. And a train will leave after every 15 minutes, right? So 15 plus 15 plus 15 plus 15, so on if you keep doing it. So there will be a train leaving T at 10:13 am and 15 minutes after this will be, sorry, not 15 minutes, the train leaves after every 10 minutes, right? Sorry, 10 minutes, sorry. So the first train leaving is 10 at 6:15. Then if you keep calculating, there will be a train leaving at 10:13. Now Priya cannot board this train. So the train leaving after another 10 minutes is at 10:23. Priya again cannot board this train. And the next train leaving will be at 10:33. So the latest train that Priya can board is at 10:33. Fine. If this is the latest train that Priya can board, in the other case the latest train Priya could board was at 10:28, but here it is at 10:33. So in this case Priya is already starting late. Okay. In the second case, when we are going from T to V to S, Priya is already starting late. And also consider one thing. When Priya was taking this route, she did not have to wait at R to change the trains. She reached at R at exactly 10:43 and she found a train to go from R to S at 10:43 itself. So there was no waiting time at R, right? Even if you consider that there is no waiting time at V, and understand one thing, the total traveling time and the total stoppage time at these stations is going to be the same. The total traveling time from T to R is going to be the same for V to S, and the time taken to go from R to S is going to be same as time taken to go from T to V, right? If we just consider that the time she spends inside the train, that is going to be the same to go from T to R as well as to go from TV to S. If that time is same, T to R it was 29 minutes, sorry, it was 15 minutes, and R to S is was 29 minutes. So same is going to be the case T to V the time is going to be 29 minutes and V to S it's going to be 15 minutes. So the total time, at least the minimum time it will take for Priya to go from T to V to S will be 29 plus 15, which is 44. So even if she starts at 10:33 and she takes the least possible time 44 minutes, considering that she does not have to wait at V. If she has to wait at V, that's a different case, but even if she does not have to wait at V, she will still take 44 minutes to go from T to V to S, and 44 minutes after 10:33 is going to be approximately how much? 11:33 plus 11:13 plus 11:24 minutes approximately. Sorry, not that. 10:33 plus 27 is 11 plus 17, 11:17. So if you consider the least time, that will be 11:17 if she does not have to wait. But if she has to wait, it will take some more time basically. But in this case, we could figure out that Priya reaches at 11:12 am, and here the latest she can reach is 11:17 am. So obviously if we have to figure out the latest time she will reach S, it can be only option A, 11:12 am, when she takes this route T to R to S. Okay. Now moving to next question. Here we are given Haripriya is expected to reach station S late. Station S is here. What is the latest time by which she must be ready to board station S if she must reach station B before 1 am? So she must reach B latest by 1 am or before that. Okay? Before 1 am itself via R. So she has to go from S to R and then from R to B. Okay? Fine. So in the previous question we calculated that just the time taken to go from R to S is 29 minutes. Just so the time taken to go from S to R will also be 29 minutes without including the stoppage time of the train at R. Just the time taken to go from S to R is this. And just the time taken to go from R to B will be how much? Let's see. North-south direction, it takes 3 minutes just the traveling time. So traveling will be from R to the station once, twice, thrice, 4, 5, 6, 7. So 7 into 3, 21 minutes plus the stoppage time of these circular stations will be total 5 minutes plus the stoppage time at T will be 2 minutes. So total 28 minutes, right? So if she wants to reach by 1 am, she should leave R latest 28 minutes before 1 am. So 28 minutes before 1 am is by 12:32 am. This is the latest she should leave R, right? Now, will she be able to board a train at 12:32 am? Well, let's see. We know the last train leaving A will be at 12 am. The last train leaving will be at 12 am. So when will this last train reach R? Let's see. 3, 3, 3, 9 minutes plus 1 plus 1, 11 minutes. So a train leaving at 12 am will reach R at 12:11 am, right? If it reaches at 12:11 am, it will leave at 12:13 am after a waiting time of 2 minutes at R, right? So the latest train that Haripriya can board is at 12, sorry, it should be 13. 12:11 plus 2 minutes is 12:13 am in the night, right? So the latest train she can board is at 12:13 am and not 12:32. This was the latest if there was a train available, but the last train available is at 12:13. There is no train available after 12:13. So she will have to board a train at 12:13 and it will take her 20 minutes. So she will reach here by 28 plus 13, 12:41 am. She reaches here by 12:41 am. But that's not the question. The question is when should she leave S, or when should she reach S to board the train. So if at 12:13 am is the last train that she can catch from R and it takes her 29 minutes to go from S to R. So the latest she should reach S by will be 12:13 minus 29 minutes. And not just reach S, she should leave S latest by this time, 12:13 minus 29. So 12:13 minus 29 minutes is 11:44, right? She should leave S latest by 11:44. If she leaves S after 11:44, she will miss this train and will not be able to reach B before 1 a.m. Then she'll have to wait for the train starting at 6 a.m. in the morning again. So she will not be able to reach on time. So this is the latest train that she should catch. So let's see if there is a train starting at 11:44 or before this. So we know the last a train starts from N at 6 a.m. the first train, and how long does it take to reach S? Let's see. In the east-west direction, 2 minutes. So 2, 2, 4, 6, 8, 10, 12. So 12 minutes of traveling time plus 1, 2, 3, 4, 5. 12 plus 5, 17 minutes. So a train starting from 6 a.m. reaches S at 6:17 a.m. and will depart S at 6:19 a.m. So the first train that will depart S towards R is at 6:19 a.m. and in the east-west direction there is a train departing every 10 minutes. So after 6:19, 6:29, 6:39, so on. So there will be a train departing at 11:19 a.m. then 11:29 a.m. in the night. Sorry, PM. This should be PM and not AM, right? 11 a.m. in the midnight, after midnight. So 29 minutes before this will be 11:44 PM and not AM. Right. So the first train starting at N leaves at 6:19 and a train leaves after every 10 minutes. So that means if you keep adding 10, in the night there will be a train leaving at 11:19 PM, then at 11:29 PM, then at 11:39 PM and then at 11:49 PM. Okay. Now the train leaving at 11:49 PM, if she boards this train, she will not be able to reach R at 12:13 AM, right? The latest she should start is 11:44 PM or before that. So the last train that she can board going from N to R will be at 11:39 PM. This is the last train that she can board from N to R. So she should reach S by 11:39 and not after that. So latest she can reach S is 11:39 PM. Okay. Let's look at the next question. Here we have what is the minimum number of trains that are required to provide the service on the AB line considering both north and the south directions. Okay. So trains going from A to B should also be sufficient and going from B to A should also be sufficient. Now for this, if you look at the directions, there was an important point here. A train must rest for at least 15 minutes after completing a trip at the terminal station before it can undertake the next trip in the reverse direction. So basically what we have is, there will be trains going from A to B, right? There will be trains going from A to B, and since we have to figure out the minimum number of trains, so we'll have to keep reusing the trains. So what we can do is, a train which reaches B will have to wait at B for 15 minutes and then we can make this train again start another journey from B to A. Then it will again wait at A for 15 minutes and then start another journey from A to B and so on, right? So let's figure out what are the minimum number of trains leaving. So let's see what is the first train. The first train starts from A at 6 AM and when will it reach B? Let's look at it. So the traveling time in the north-south direction is 3 minutes. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Traveling time is total 10 into 3, 30 minutes. Plus you have stoppages time 1, 2, 3, 4, 5, 6, 7. 7 minutes of stoppages time at these circular stations plus 2, 4 minutes of stoppage time at the junctions. So the total time taken to go from A to B will be 41 minutes. So the train which leaves at 6 AM from A reaches B at 6:41, right? And this same train will have to wait for 15 minutes. So the latest that this train can start from B towards A will be 15 minutes after this, which is at 6:56 AM. right? So this train can start. So if this is the first train that can start from B, and there will be trains coming every in the north-south direction, you have 15 minutes. So after every 15 minutes there would be a train coming from A, and that train will wait for 15 minutes and then again start its journey towards B. But before that, at 6 a.m. there is also a train that has to depart from B, right? So at 6 a.m. there has to be a new train to be used from B. Similarly at 6:15 there has to be a train that has to go from B towards A. So this train again cannot come from A. In just 15 minutes the train cannot come from A. So this has to be a new train to be used. At 6:30 a.m. also there has to be a new train to be used. At 6:45 a.m. also there has to be a new train to be used. And after that at 7 a.m. do we really need a new train? No. At 7 a.m. this train is free, right? This train is ready to start. So at 7 a.m. we can make those trains start from B which came from A, right? So at 7 a.m. this train can start. At 7:15 a.m. a train, another, after 6:41 there will be a train coming from A every 15 minutes. So at 6:56 there will be a train coming from B, and this train will wait for 15 minutes. If it waits for 15 minutes, it will wait till 6:11. So at 7:15 this train can leave from B to A. At 7 a.m. this particular train can go from B to A, and this sequence will keep going on. So the only new trains required at B will be these 4 new trains. After that, every 15 minutes we can use a train coming from A towards B to go back from B to A. So there are 4 new trains at the starting of the day that are required from B. Similarly, there will be 4 new trains from A also at 6 a.m., at 6:15, at 6:30 and at 6:45. So from A also there are 4 trains required, new trains, and from B also there are 4 new trains required. So the total number of new trains required on this route A to B is 8. 4 from A, 4 from B. These 4 trains will go from A to B and again start from B to A, then again go from B to A to B, and so on. This sequence will keep going on, and the only fresh trains that we require will be the initial 4 trains from A and the initial 4 trains from B. Okay? And moving on to the last question. This is pretty much the same as the previous question. Here we have, what is the minimum number of trains that are required to provide the service in the city? Okay. So on this route A to B, we know there are 8 trains required. On the route A to B, there are total 8 trains. Similarly, on this route C to D, there will be 8 trains required, right? Now let's look at route MN and route PQ. Fine. What is the time taken to go from M to N? Let's check that. We had actually calculated the time taken in the first question to go from M to N. It was 61 minutes, right? So the first train that leaves at M leaves at 6 a.m. and reaches N at 6:41, right? And it will have to wait for 15 minutes, sorry, not 61 minutes, right? Sorry, so it reaches at 7:01. 61 minutes is the total time to go from M to N. So it reaches at 7:01 a.m. and it will have to wait for 15 minutes, that is till 7:16, when it can start back again, right? So till 7:16 a.m. we will need fresh trains from N to start and go towards M. So we will need a train at 6 a.m. and in east-west direction there are trains every 10 minutes, right? So at 6 a.m. we'll need a train, at 6:10 we'll need a train, at 6:20, 6:30, 6:40, 6:50, 7, then you'll need a train at 7:10, and at 7:20 this train again can go towards M. So how many fresh trains do we need, or new trains? 1, 2, 3, 4, 5, 6, 7, 8. 8 trains to go from N to M Similarly, you'll need 8 trains to go from M to N also, just like what we did in the previous question. So on MN route, you need a total of 16 fresh trains, 8 from N to M and 8 from M to N. Similarly, you'll need 16 fresh trains on this route PQ. So the total trains that we require is 8 plus 8 16, 16 plus 16 is 32, 32 plus 16 is 48. So we'll need total 48 trains to provide the metro service in this city, right? So that's it for this set. Thank you.